So at the end of the last video, I mentioned I was going to look into better ways to automate the testing of these little various boost converters that I've been working on. Well, I think I found one. Note that we now have 3 devices set up, and let's look at the new test setup. So like last time, we have the power supply, the boost converter, and the source meter. The source meter will continue to be the load, and what we've added is between the PSU and the boost converter, we've added a DMM. And this isn't just any one, it can talk to the SMU. So that means what I can do is I can run a program on the 2450 source meter and communicate over a TSP-Link to the DMM and ask it for the power consumption, the input power current with each different load. So all I have to do now is enter the starting voltage, trigger it to run, set the next starting voltage, trigger it to run, and we'll get our data. And all of the data will be written out to a USB stick. Perfect. All right, we have it all wired up. The source meter is on the output, which are the blue and yellow wires going here. The power is coming in off the red and black clips. The ground is coming in from the negative is coming in from the power supply. The positive is coming in from the 7510 DMM, and then that is connected down to the power supply as well. So all we have to do now is run a script, and from that we hit menu, and one way to run a script is directly off the USB stick. Press scripts. My scripts appear here, so I'm going to run this one. Oh, switch to local control. I was running this remotely, so I'll say yes. And here we go. Takes a moment to start up. It's doing some initialization in here as well. We're going to go for let's go for a log run. We'll start at 10 microamps of load. I don't have to put in a negative. Now we need to enter the stop current, which is going to be 30 milliamps. We'll do it and keep it simple. Let's just do 5 steps. And now we need to set the supply voltage. So I'll go down to the power supply and enter 1.5 volts. And I'll turn that on. I'll enter 1.5 volts. And we're off to the races. You can see the source meter is starting out in the microamp range. The power is slowly ramping up here. You can see the DMM is now recording the input current at each step. Now, do we want to run another sweep? Sure. And I will do that for, let's try 1 volt, just to keep it simple. So I enter 1 volt on the power supply, and I set that to 1 volt to tell the software what the input voltage is, because that does not change much over the course of the test, because we're not really loading up these wires very much. Now I've got this set to fairly slow so that everything can stabilize and we can get good readings. Do we need another sweep? No, that's enough. And now the data is on the USB key. And here we can see the files on the USB key. And there's the spreadsheet. Let's zoom that up a little bit, make it easier to read. Here are all the various readings we have, all 10. We have the first 5 at 1.5 volts, followed by the next 5 at 1 volt. Now, to make a nice graph of this, I really probably need to take these 5 and manipulate the data a bit. And by shifting the data a little bit, I moved the 1 volt results up to here, so it was in its own little column, made it a lot easier to select the results. Here's the load in current, and so we can see that as the load in current increased, the curve for each 1.5 in orange and 1 volt in gray went up in efficiency. Here's the efficiency on the left, 1.00 being 100%. So now we can make nice clean graphs very easily with data and not having from the source meter without having to go through and manually key it in. It's fairly automated. I still have to set the source voltage and tell it what the next one is, so it isn't completely automated, but I'll work on that and see what I can do. Anyway, very pleased with the results. I just need to do more test runs with it and get more, a little more in the way of points of efficiency. But you can see the voltage, the efficiency drops off just a little bit as the source input voltage goes down. Now I did take it from 1.5 all the way down to 1 volt as the input, which is a pretty big difference on the input, and that really drove up the current on the input. So that probably explains the difference in the efficiency of the drop. But anyway, very happy, looking good. So how does it work? Well, there's a small script inside the source meter, and this is what's in it. It comes to a little over 100 lines with the comments in it, but it's actually pretty easy stuff to write once you kind of get used to it. We have an initialization for the at the beginning of the script. Then we communicate with the DMM and configure it to take current readings and we set the reading ranges, amps, and so on. We then, you saw the little menu pop up where I entered the data, the test parameters, so we query the user for that. Then it goes into a loop, and at the beginning of the loop we're going to ask for the voltage, input voltage. We then set up the source meter and generate either the log or the linear sweep pattern, so that's what we do. And then for each test sweep, for each step in that list of generated parameters, then we load the parameters into the SMU. We tell it to set those as the current run parameters. We tell it to execute, take the reading. We read the DMM, so we call over TSP-Link back to the DMM and ask for the reading. And then at the end of that loop, we save the data to the file. And just another query to ask, do we run another test? Yes. I entered the 1 volt. We ran the 5 steps, reading the data off the DMM each time, saved the data out, and then I said nope, so we exited. And that's all there really was to that. There's a little bit of interesting stuff going on. Let's look at the script. And this is the Keithley TestScriptBuilder. It's based upon Eclipse, and what you do is you write Lua scripts. And I won't talk too much about Lua, but it is a scripting language, an embeddable scripting language. It's used in various things. It's been around a while. Seems to have pretty good documentation, and so I've been in their manual to look at some of the math functions and things like that. So there's plenty of documentation on that. And the Keithley TestScriptBuilder comes pre-populated with a whole pile of example scripts, and they even explain what it is you need to look at first before you actually run the script. So they'll even show you how to configure the meter, and then walk you through the script, some of the details of it, and then you go and look at the source code itself, and you can run it, and it's great. So I'm really impressed with all the work they've put into with all of these examples. So I have created sweep log 3, that remote sweep log. This is going to run on the 2450. It calls the 7510 to get readings, and then it saves the output to the USB stick. So there, you can in Lua you can create functions. So I broke this out into a few functions, and the first one is setting up the source meter. And so some of these are set for can be set up so you could set it to 4-wire sense, but I didn't actually want that. This sets up the source meter to measure voltage and auto ranging NPLC 10, and then for a nice stable reading. Source settings in there are to source. The source function is a constant, and that is SMU.function DC current. So there are various constants already defined, and you can look those up in the help documentation. There's a ton of help out here. You can select just your command reference, so the 2450, and go into the TSP commands. There are lots of extra information. So I can do SMU, and we were looking at source function, and it provides, they've got a great help in here. Here are the two constants that you would need to use for voltage or current, and a little example. And some of the examples are maybe a dozen lines long if it's a more complicated command. So very good help. Don't be afraid to use that. Get in there, go through it. In fact, what I did was I read through most of it and then began writing my scripts. So I have a function to set up the source meter, and if the user has selected a current sweep, then I tell it to create a current sweep, and that's what this command does, with the beginning current, ending current step, and a delay, or a logarithmic sweep. It's a quick setup for the DMM. All we do is reset the unit, tell it to measure current, set the range to 1 amp, enabled auto 0, and set the NPLCs. And that was it. Next up, we have the test parameters UI. This was a set of screens that you saw pop up where I keyed in the data, and it was very simple. This was a selection list with the heading select sweep type, and here are the two option buttons that came up. If they click cancel, if they tap cancel, we're going to see the value equal nil, and then in that case I want to exit the program. I don't want to continue. Then continuing on with the next input was the starting current, and we can even tell it a prefix, and we can put in min-max values and things like that. Again, the ending current, and then an integer for the number of steps, and that's it. If they click cancel on any of those, we will exit that out. So we call these in order, we reset the instrument, we clear out the data buffer, and we created an array here for the output amperage. And actually, PSU voltage is not defaulted to 1.5 really. That's keyed in by the user. One of the things we have to do, since we're talking to another device over TSP, we need to go out and find node 2 in the TSP network. Now, TSP is not over Ethernet. It does use crossover Ethernet cables to connect the devices together, but they aren't quite, it isn't Ethernet. It's a very proprietary protocol, I believe, and it has additional functions beyond just data communication. There's actually hardwired triggers available across that cable, and I haven't used that yet, but I may in my next script. We'll see. In any case, you have to set up your communication with them, and I just show that on the screen that the link is working. And on the screen, when I'm working remotely, down at the bottom there is a console. because you can run all this remotely. You can just say run editor contents and it will call up the device you're connected to and send everything over. So we call the test setup function, then we call the function to get the input data, the input parameters. We define the file on the USB key, and I just hard-coded a file name because that was easiest than trying to type one in every time. And since I'm creating a CSV output file, I went ahead and put in the headings for the columns. Then we get into the main loop that I showed on the paper, and at this point we ask the user to enter the supply voltage because we're going to do this sweep at multiple voltages, but I need the opportunity to key that in for each sweep. If you cancel that, then it will end. We do a chirp to say we're starting the sweep. We clear the data buffer before each sweep, so you need to do that each time. Then we call the SMU setup to set up the parameters for this. And then for each sweep, for each step in the sweep, so as we went from 10 microamps up to 30 milliamps, for each sweep we do a small loop. We take the configuration list, that's called iSweep, and when I generated that up in the SMU setup, I said create a sweep and call it iSweep, so for current sweep. And now we're going to use that down here. Not all of this is completely clear in the documentation, but it's pretty good. I figured it out by reading the examples and by looking at the help on what the config list, how the config list works and when I call that. Then for each of those steps, we recall that data, that step of the generated parameters, and put that in, set that as what the meter is going to use for its settings, then turn it on. And I gave it a pause to let everything settle, and then we read the DMM, and so we're calling source, telling the source meter to take the readings. I paused again, and then we call the DMM to take the reading. And to do that, you say node 2, because that is the node number for that DMM. We call the node, we call it node 2, because that's the node number for our DMM. And then we just append to that the DMM command. And so a DMM7510 uses a command DMM, tell it to measure and read, and that will return the data. I gave it a small pause at the end, and after the end of the loop, for each one of these we do this, and in the array we record at that position in the array we record the DMM's measurement. At the end of the loop we delay, turn off the output of the source meter. At this point I print the results directly on the screen here. If you're running remote, you'll see those in the debug console. And here, as long as the file got created, we write the data out. And again, you can use simple C string format. It was easy. If you don't know that, you need to go look that up, but this is pretty universal. And all I did was put in a series of comma delimited parameters and a carriage return at the end. At this point, I print the PSU voltage that was keyed in by the user, the amps read from the DMM for that step. Then I multiply that out to get the power. So the voltage times the current to get the power. That becomes our input power. Then we have the from the buffer, the output of this step, of these steps for this sweep on the source meter gets stored in the buffer that we cleared. And so we just go through each of the readings on that step by step. So we take the readings at that step, and then I took that times the source value, which was the negative 10 microamps, and I absoluted that so that I got positive. Then I compute the power. This was the load side power, current times voltage. And then take that and divide it by the input, and that gets us the efficiency. So those are the 7 parameters that get printed out into the file. Pretty straightforward. And then that's really it. We announce that we're done with that sweep, ask the user if they would like another one. When we're done, close the file. There you go. Not much to it. It looks complicated, but you can break this up and build it out bit by bit. My first script was just to have the user key in a frequency on the with a simple input, and then play a tone and did a loop until, and so I stuck with that. Then I created a more advanced menu right here, just to try out the whole menu parameter thing and figure out what happens when the cancel button was pressed and so on to exit. So just build it up step by step and you'll have no problems really. And the Keithley tech support also is really great, and the field engineers will help with this if you hit something more complicated. But really, it was pretty straightforward, as you can see, with a lot of comments in it and a lot of blank space, 136 lines. So these are easy to build. I haven't gone through and used the debugger yet, really. So there's a lot of features of this that I haven't leveraged. But it's easy to do. You can have 2 different devices connected together, and they can talk to each other. And I can even have, I think I can set this so that put a script on the DMM itself, and then trigger that script to do more complicated things from the source meter, or vice versa. This script could have been installed on the DMM, and I could have had it control everything. So there you go. Really liked the Keithley script builder and how the scripting functions work. I was a little concerned when I was looking at this, going, oh, how am I going to figure out all of this? But it is Lua, and there's a lot of interesting information out there. So they didn't just, Keithley did not just go out and build their own, write their own scripts, scripting language and all of that. They did it what I think is really the right way, by going with something that's really open source and common. So this is really great. So there you have it. That's the semi-automated testing of a boost mode power converter using a Keithley source meter and DMM7510 with a script to make it a lot easier to run the tests. I like these. This is a great stack of equipment. It's very powerful. There's a lot I can do with it. There's a lot I still have to figure out. And so there will be more to come on that. This one got a little long with showing the program, but I felt it was important to show and step you through the script and explain how straightforward it really is to build a script, run it, test it, and get it going. It's really been fun to work through this.